Coming from galaxies far away, there is a mind-blowing phenomenon hidden in the night sky. It's called luminous fast blue optical transient, or LF-BOT, and it's like nothing we've ever seen before. These dazzling bursts of light are a sign of some explosion in space, but they're rare and flash at peak intensity for hours instead of gradually fading away in months like all known supernovas, the explosive death of stars. First discovered in 2018, only 8 similar events have been observed across the vast expanse of the universe. A fascinating debate on what could be causing these cosmic fireworks has been raging ever since. The first luminous fast blue optical transient discovered has been labeled as AT 2018 COW, according to the naming protocol, and nicknamed the Cow. The Cow suddenly appeared in June 2018, directly with a high intensity, brighter than normal supernovas. The news of its sighting was shared with the community by Stephen Smart through the Astronomers Telegram, a platform for reporting and discussing astronomical observations. Its unique characteristics sparked interest and curiosity among the scientific community, and many teams of astronomers all around the world put down what they were doing to look at it, including using 24 of the major telescopes. The Cow was not just brighter and faster. The light was also predominantly blue, and disappeared after just a few days, another characteristic that set it apart from other celestial phenomena. Almost everything about it was surprising. Although it may sound like it, observing LF-BOTs isn't as simple as pointing a telescope at the sky and waiting. The universe is vast, and these optical flares are fleeting. To capture them, we need technology capable of scanning large swathes of the sky quickly and accurately. Here, the role of wide-field telescopes came into play, capable of capturing detailed images with rapid succession in time-domain surveys. This technique scans the sky at regular intervals, creating a chronological record of changes. By comparing these snapshots, we could identify the sudden appearance of an LF-BOT, a flash of light that wasn't there before. The first related peer-reviewed research article published in the astrophysical journal Letters is entitled "The Cow: Discovery of a Luminous, Hot and Rapidly Evolving Transient," and reports the observations by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Hawaii. On this figures you can see the location of AT 2018 Cow before and during the event, and the difference between the two seen here reveals clearly this black spot, which is actually the very bright spot of the Cow. Observing luminous fast blue optical transient isn't without challenges. The biggest one? The ephemeral nature of LF-BOTs. These flares are here one moment and gone the next, often disappearing before we could gather enough data. This makes every observation crucial, every second invaluable. Since the discovery of the Cow, astronomers have become more alert about LF-BOT and doubled effort to find them. It is still a rare and difficult task, but fortunately since 2018, 7 other LF-BOTs have been detected, for example in events nicknamed the Koala, the Camel, the Finch, and each being an exciting event for astronomers. But the weirdest one of all these already weird events is the one observed in 2022, about 1 billion parsecs away, labeled AT 2022 TSD, and nicknamed the Tasmanian Devil. Its discovery has been reported last month in the prestigious scientific journal Nature in an article entitled "Minutes Duration Optical Flares with Supernova Luminosities," a title that summarized well what the Tasmanian Devil looked like, that is to say a series of flares as bright as a supernova, but just lasting a few minutes, while supernova usually lasts for months or years. The Tasmanian Devil is a particularly weird LF-BOT because it pulsed intensely at least 14 times for just a few minutes each time. That is shorter than previous LF-BOTs, but spread over 4 months. This paradox of being incredibly bright, yet incredibly brief and recurring, is what makes the Tasmanian Devil such an intriguing subject of study. Such behavior wowed the community. One of the peer reviewer particularly insisted that this behavior was unprecedented. Each observations were conducted to understand this fascinating phenomenon. Astronomers used 15 powerful telescopes to observe this Tasmanian Devil, capturing critical data about the luminosity, color, and duration. They analyzed the data, trying to understand what could possibly cause such intense, short-lived bursts of light. But first, let's lay down some of the main possibilities previously proposed. Over the years, various theories have been put forward to explain the origin of these enigmatic LF-BOT flares. One such hypothesis suggested that LF-BOTs are the result of a supernova explosion, as it's one of the most energetic events in the universe. This theory proposes that when a star explodes, it expels its outer layers at tremendous velocities, producing a bright blue light that we perceive as an LF bot. It could also be a failed supernovae, stars collapsing into a black hole or neutron star before they can explode, or a dwarf novae, a subclass of cataclysmic variable outbursts with fast blue light. Another possibility is that LF bots are born from the collision of neutron stars. Neutron stars are the remnants of massive stars that have already undergone a supernova explosion. When two of these celestial heavyweights collide, they may release an enormous amount of energy, potentially enough to create an LF bot. Other hypotheses were that LF bot are the results of black hole interacting with hot, bright stars known as Wolf-Rayet stars, magnetar, accreting black hole. And last, for the fun of it, I will also mention that our dear viewer Billy Nixon proposed that it is coming from an intergalactic war, so shout out to Billy, but we will not dive into this proposition. In any case, the universe is complex and often doesn't adhere to our neatly packaged theories. Some serious scientists argue that neither of these hypotheses fully explain the characteristics of LF bots. They point out inconsistencies and gaps in our understanding, fueling the debate and driving further research into these mysterious phenomena. This large number of proposed origins and rush for publication are proof that LF bots are such a hot and important topic. This is why the observation and analysis of the Tasmanian Devil has been such an important milestone in this field, as it offers new clues on its origin. To make a long story short, the team of scientists were able to narrow down the answer to either a rotating magnetar or an accreting black hole. To conclude this, authors rigorously eliminated other options in light of the newest data. For example, it cannot be a dwarf novae, as they cannot achieve such high brightness. Neither can it be a classical supernova, as there is no galaxy in the right place for it to work, nor its other usual characteristic spectral features. The fact that the light reappeared after some time, as brightly as the original flare, eliminated some other options. Similarly, the peak light measurements did not fit other possibilities. At the end of it, the most likely origins left are a rotating magnetar, where we can only observe the outburst coming directly toward Earth, or a tidal disruption even of an intermediate mass black hole which formed an irregular accretion disk. The truth is, even experts are still not entirely sure what causes the Tasmanian Devil and other LF bots. They defy easy explanation and remind us of the vastness of what we don't know about the universe. But that's what makes the quest for knowledge so exciting. Each question leads to new hypotheses, each hypothesis sparks more questions, and the cycle continues. Hopefully more observations could give the definitive answer. Assistant Professor Anna Ho, the corresponding author of the Tasmanian Devil paper, mentioned that a new telescope system, the Vera C. Rubin Observatory, is under construction in Chile and may better fit to find more of these objects. We shall see this, so don't forget to subscribe to our channel. The universe never ceases to intrigue us, pushing our scientific prowess to the limits. But every challenge brings us closer to the truth.